All right, so let's kind of work through it, see what we got here. And learn from our mistakes, because it's only really a mistake if we don't learn from it, right? The only true mistake is the one you don't learn something from. All right, so we started out with I to the 17th power. Well, remember the trick to this is take 17 divided by 4. Now, if you don't like the long multiplication or long division way, fine, do it in your calculator. 17 divided by 4 is 4.25. So we ignore the 4 and we take the 0.25. 0.25 means we have a remainder of what? 4 1/4, right? The remainder is the 1. 0.25 is 1/4. So that means that this is I to the first power, which is I. Okay? A lot of people said negative I on that one. It's just I. Same with 6, I to the 5/21. Again, even if I do 521 divided by 4, again, it's 130.25 in my calculator. Well, it doesn't equal that, but we have 130.25, or 130 1/4. The only number that really concerns us here is that one. That's I to the first power, or I. That's all we have to concern ourselves about. And remember our progressions of the power of I. I equals just I. I to the first equals I. I squared equals -1. I cubed is I times I squared, or negative I. I to the fourth is 1, and I to the 0. And then we just repeat. I to the 0 also is 1. So now it just repeats. So I to the 5th is I to the 6th is -1, and so on and so forth. Really, we only need the 0 through 4 progression to get our solution for any power of I. So some people just, frankly, just didn't know that. They didn't know their progression of the powers of I, and that's important to know. At the very least, if you don't remember it, you can always rederive it, because you know that I equals the square root of -1. So I squared would be the square root of -1 squared. Square root and squared cancel out. That's -1. I cubed is, then once you have these, is -1 times I squared times I. And anything to the 0 power is 1. So right there, we've got it all figured out. So it doesn't matter, you got it, but somehow you do have to know your powers of I. And that's just memorization. So 2, -3i to the 30th power. Again, I to the 30th, 30 divided by 4 is 7.5, or 7 2/4. Well, I to the second power is -1, so it's -3 times -1, which is 3. A lot of people miss 1, 2, and 6. Now, that's only 3 points, but that's 10% of the score on this test. Square root of 3 plus 4i squared. This is not a place to convert to polar form and then do it that way. It's just squared. for just squared, we'll just FOIL it out. That's square root of 3 plus 4i times square root of 3 plus 4i. I did have a few people who just distributed the exponent. Square root of 3 squared is 3, 4i squared is negative 16. And that's all they did. But you have to FOIL it. And again, I just refer you back to the same thing I say to my geometry students when they start trying to do that. Because people just naturally try to distribute the exponent. We have to break that habit. But if I take 3 plus 4 squared, order of operations says we have to do the parentheses first and then the exponent. So that's 7 squared, which is going to be 49. That is not the same thing as 3 squared plus 4 squared. Because that would be 16, or 9 plus 16. Well, yeah, I guess I screen change the order. That would be so smart. Okay? I cannot just distribute the exponent over a sum or difference. Yet I still see some people trying to do that. That's an algebra mistake that needs to disappear. So I FOIL it out. Root 3 times root 3 is 3. Root 3 times positive 4i is plus 4 root 3i, plus another 4 root 3i, then plus 16i squared. I squared is negative 1, so that's going to be minus 16. And now we have to combine like terms. 3 minus 16 is negative 13. 4 root 3i and 4 root 3i gives me an 8 root 3i. Or, if you want to do it this way, it really doesn't matter. But what you should not do, and I saw a couple people doing, they put the I first. And generally that is considered improper. It's not incorrect as much as it is improper. Whenever we express a complex number, we do it in the form a plus bi. Remember the book did one backwards in an example, and I said that was dumb. Why would they do that? Okay, we always say a plus bi. And even if it's negative a plus bi, that's fine. We always do that order. We don't do the put the bi first. We don't put the complex portion first when we're doing that. I didn't take off points if you switched it, but certainly that's something that you should have been watching. Number 4 actually went much better than a lot of the other problems in this section. It was probably the hardest one there. But 1 minus 7i over 1 minus 4i. People figured out multiplied by the conjugate. And then FOIL it out. So that's 1 plus 4i minus 7i minus 28i squared. So the I squared gives me a plus 28 there. And then denominator, it's 1 minus 4i plus 4i minus 16i squared. I squared is negative 1, so that becomes plus 16. Combining in my denominator, 1 and 28 is 29, minus 3i over 1 plus 16 is 17. Some people do want to get the more perfect complex form. They say it's 29/17 minus 3/17 I. That's really not necessary, but if that's what you want to do, that's okay. Number 5 wound up being negative 8 plus 9i. So again, kind of the same types of things. So just watch. I mean, really 1 through 6 was basic algebra and working with things and knowing your powers of I. And people who messed up on those, that's what we were struggling with. Switching from complex to polar form and polar to rectangular. Okay. So rectangular, polar to rectangular, we're still having some difficulty with that. Quite honestly, the biggest problem we're having with this is quadrants. I can't emphasize enough. We've been talking about this. I've said it a lot of times. Do a quick sketch before you get going on these problems. It doesn't have to be fancy. But if you're going to use negative 4 root 3 plus 4i, okay, it doesn't have to be perfect. I just know my x-coordinate, my horizontal coordinate is negative, and this one's going to be positive. Okay, so we're somewhere over here in quadrant 2. If I plot that in the complex plane, where this is the real axis, this is the complex axis, we're going to be over there. So I'm going to be in quadrant 2. So when I set things up, I mean, my radius is the square root of negative 4 root 3 squared plus 4 squared. My theta is the tan inverse of 4 over negative 4 root 3. Or 1 over root 3. Or inverse negative root 3 over 3, which is identity. And my radius winds up being 8. When I do this out, that winds up being 8. Tan inverse of negative root 3 over 3, I shouldn't even need a calculator for that one. That's negative 30 degrees. And the calculator will give it to me. But again, this goes back for a lot of you to the fact that you never memorized your identity angles and the sine, cosine, and tangent of your identity angles. And that's still creating problems for a lot of people. And believe me, if you get into calculus next year, it's going to continue to create problems. It's not too late to start doing that if you haven't yet. Problem is, negative 30 is not my angle. Negative 30 is down here. That doesn't help me one bit. It's the wrong direction. I guess I could make my radius negative, but more likely what we should do is actually just use our actual angle, which you have to add 182, so that's 150 degrees. So it's 8 cosine 150 plus I sine 150. So we do have to go through a quadrant change to 150 degrees. Negative 30 is not the correct angle because it's in the wrong quadrant. A lot of people have the quadrant error in there. A lot of people have the quadrant error. So sketch. Do a sketch. See where your point is before you start working with it.
Could you go back to the R and show how you got the 8, like kind of like write it out? Like how did you
negative 4 root 3 squared, so that would be 16 times 3 plus 16. Because negative 4 squared is 16, root 3 squared is 3. You're multiplying those. 48 plus 16 is 64. Square root of 64 is 8. 2 minus I. All right, quick sketch. 2 minus I, about there. All right, we'll be in quadrant 2, or quadrant 4. So R is the square root of 2 squared plus negative 1 squared. That's the square root of 5. Theta is a tan inverse of negative 1/2, which is not identity. Negative 1/2 would be identity for sine and cosine, but not for this, and that's negative 26.6 degrees. So this would be root 5 cosine negative 26.6 plus I sine negative 26.6. Some people did convert this to the corresponding positive angle, so negative 26.6 obviously goes this way. Some people did the 330, what is that, 333.4 instead. It's the same angle. And this is no different. This is the exact same problem, just for reference for the chapter test as we get to it, as the point 2, -1 in XY coordinates, switching it to polar. Okay? We just don't get the I in there. It's the same process. Okay? R is going to be √5. Theta is -26.6. We don't write it R cosine theta plus I sine theta. We just write it R theta. But it's still the same R and the same theta. It's the exact same process. So if it's rectangular coordinates to polar coordinates or complex numbers to complex polar, the process doesn't change. The way we express a number does a little bit. Going the other way, 2 cosine 3 plus I sine 3. That 3 is in radians. It doesn't say 3 degrees, it's 3 radians, so we have to switch our mode to radians. And all that is we multiply out 2 times cosine 3. Oops. 2 cosine 3 in radians is -1.98. Because the angle is given in radians. Okay. Sine 3. Sine of 3 radians is 0.1411. Wait a minute. Wait a minute. Oh, 2 sine 3. Sorry. That's what I did wrong. 2 sine 3. That's okay. Okay, that's to distribute. So 2 sine 3. 0.2822. There we go. And that's not an identity angle. Now, for 10, it's an identity angle. 10 cosine 3 pi over 4, I sine 3 pi over 4. This is a little harder because I'm not sure exactly where 3. I mean, 3 is a little less than pi radians. So if you wanted to sketch that one, that's over here somewhere. A little bit less than pi. And that makes sense. 3 pi over 4, okay, 3/4 pi is going to be right there. Okay, so I'm radius of 10. There's 3 pi over 4. Just so you know where you're going to wind up. Cosine of 3 pi over 4 is -√2 over 2. Sine of 3 pi over 4 is +√2 over 2. So that gives me -5√2 plus 5√2i. All right. And again, that's just knowing complex, knowing identity angles. A lot of people would give me the wrong values or decimalizing that. We do not decimalize when we have identity angles. If you see 0.707, you should know at this point that that's going to be square root of 2 over 2. I mean, these are things we've written down many times. 0.5 equals 1/2. 0.707 is √2 over 2. 0.866 is √3 over 2. If you have to use your calculator to find those angles, fine, but at least be able to convert that identity angle back to its actual radical value, not the decimal approximation. We're way past that decimally approximating identity angle thing. Should never be happening. One minus I to the sixth power. This is where we are not going to FOIL this out. We're going to go ahead and use D theorem, as I like to call it. So I'm going to need to convert this to polar. So R is the square root of 1 squared plus negative 1 squared, which is 1 plus 1, which for most of us is 2. Theta is the tan inverse of negative 1 over 1, which is negative 45 degrees, or 315, depending on how you want to express it. Make sure we're in the right quadrant. 1 minus I, positive 1 minus I. There's my sketch. Yes, that is in the correct quadrant, negative 45 degrees. Or if you choose 315, it doesn't matter. It's all going to work out either way. And so in polar form, this is root 2 times cosine negative 45 plus I sine negative 45. We're going to raise the whole thing to the sixth power, which means that's root 2 to the sixth times cosine 6 times negative 45. 6 times negative 45 is negative 270. Yes? Yes. Plus I sine negative 270. Okay. Root 2 to the sixth power would be 2 to the third power, or 8. And you could do that in your calculator. Cosine of negative 270. Well, negative 270 is actually 90, isn't it? Okay. And cosine is going to be 0 plus I sine negative 70 plus I times 1. So 8 times 0 is 0. 8 times 1 is 8. So that's 8I. I mean, the repetition in what's going on here is almost startling sometimes. We just keep doing the same thing over and over. There are a few minor adjustments. If you did 315, by the way, you still wind up, when you multiply by 6, at 90 degrees. It's 315 times 6, which is 1890 degrees. But if I take if I put in the right mode, please, thank you, degrees. But if I take the cosine of 1890, it's still 0. And if I take the sine of 1890, it's still 1. So it didn't matter if you did the negative 45 or the 315. That was going to be great if this was one changing, but I just haven't been. Cube root of negative I. This is actually one of the tougher ones, I think. Because this is the cube root of 0 minus I, or 0 minus I to the 1/3 power. This was key to our understanding. Getting that cube root of negative I into the 0 minus I to the 1/3 power. Because once it's in this form, it's exactly like every other problem. 0 minus I. Let's see now. Over 0, down 1I. Oh my goodness, I don't even need to run a calculation here, because I can tell my angle is negative 90 degrees. And I can tell my radius must be 1, because that's 1 unit down. So, expressing this in polar coordinates, it's 1 cosine negative 90 plus I sine negative 90, whole thing to the 1/3 power. Now, this will make a little bit of difference if you choose 270 or negative 90. You'll get different answers. Both are correct. Because we know that there are 3 cube roots of negative I. If you chose 270, well, I'll show you both ways here real quick. If I do it this way, this is 1 to the 1/3 power, which is 1 times cosine negative 30 plus I sine negative 30, because 1/3 of 90 is 30. Cosine of negative 30 is root 3 over 2. Sine of negative 30 is 1/2, negative 1/2. And 1 times that is just that. If I'd have gone with the positive angle instead, 270, okay, whole thing to the 1/3 power. If I do it that way, I get 1 cosine 90 plus I sine 90. Cosine 90 is 0, I sine 90 is 1, so that's just I. Both of these are correct answers. Because, like I've said before, these are going to give us multiple solutions. The cube root is going to have 3 different cube roots. There's actually a third one, too. It's negative root 3 over 2 minus 1/2 I is the third root. And that gets back to that thing that we were not focusing on so much. But basically it comes down to either answer is acceptable. 13. We had 3 root 2 cosine pi over 4 plus I sine pi over 4 times 2 cosine 3 pi over 2 plus I sine 3 pi over 2. Can't tell you how many people the radian measure messed up. People who could not add pi over 4 plus 3 pi over 2. That was the issue on this problem. Not being able to work with angles in radian form. But some people switched them to degrees and said, well, that's 45 and 270. I guess that's okay. But honestly, you should just be able to add pi over 4 plus 3 pi over 2. I mean, come on, folks. That's pi over 4 plus 6 pi over 4 is 7 pi over 4. That's identity. Okay? We're multiplying, so we're going to add those, multiply the outside, so that's 6 root 2 on the outside. Cosine 7 pi over 4 plus I sine 7 pi over 4. Cosine of 7 pi over 4 is root 2 over 2. Sine 7 pi over 4 is negative root 2 over 2. I have to distribute that. 6 root 2, well, root 2 times root 2 is 2. 2 over 2 cancels out, so that's just 6. Root 2 times root 2 cancels out, or it would be 2 over 2 cancels out, so minus 6i. Everything reduces. 6 minus 6i. 14 gave it to us in degrees, which is a little nicer. Now, what's 1 divided by 1/2? 2. A lot of people did 1 divided by 1/2 is 1/2. 1 divided by 1/2 is 2. So this gives me 2 cos 90 plus I sine 90, because 120 minus 30 is 90. Cosine 90 is 0, so that's 2 times 0 plus 1i is 2i. Consider the equation 15. The first part counted it for 1 point. The second part, not so much. How many complex roots does the equation have? It's x to the fourth plus 4 equals 0. So that's x to the fourth equals negative 4. Or x equals the fourth root of negative 4. Okay, which is negative 4 to the 1/4 power. Okay. Or, if you prefer, negative 4 plus 0i to the 1/4 power. So there are going to be 4 roots of that. There are going to be 4 roots. So that first part, there are 4 roots because it's to the 4th power. Okay? Then these are my roots. Now I have to actually find those roots. So we're going to put that into polar form. So r equals square root of 4 squared plus 0 squared, which is 4. Theta is the tan inverse of 0 over negative 4, and which is 0 or 180, so which is actually 180 degrees in this case, because again, negative 4 plus 0i is over here at 180. If I graph it, which would be 0 degrees, but we have to add 180 because we're in the wrong quadrant, so theta is 180. So in polar form, this is 4 cos 180 plus I sine 180 to the 1/4 power. Or 4 to the 1/4 power times cosine 45 plus I sine 45. 4 to the 1/4 power is the square root of 2. Cosine 45 is root 2 over 2 plus I root 2 over 2. So that's 1 plus I. Now, that's the first root. Having fun? This is the good stuff. So we got 1 plus I. Now we need to find our other roots of this, and this is where it gets interesting. And again, this is the part that I'm not testing you on, but in case you're wondering the way it works, remember that there are 4 roots. The first one is at 1 plus I. If there are 4, that means that it's going to be every 90 degrees around here that this is going to happen. And very quickly we see the symmetry in this. This is going to have to be negative 1 plus I. This is going to have to be negative 1 minus I. And this is going to be 1 minus I. Those are my 4 roots. Now, like I say, you are not responsible for this. That was extra credit to find all 4 roots, but that's where they come from. But this part, at least finding the first root, should have been pretty possible. But again, it's a matter of expressing that as negative 4 plus 0i, and then working from there to the 1/4 power. So that pretty much takes us through the entire quiz. Look over it. Look over the notes you put online, stuff like that. Learn from what we did wrong. We'll look over the first quiz on Monday, and then on Tuesday we will be taking the test. Yes, you may keep the quizzes to study from, because everyone's taking it now.